Hello Internet, welcome back to our grass renderer. In this video we are going to be changing our grass a little bit. Right now we have wind and a few other things. There's no lighting or anything like that. I want to change that a little bit. I've had this really bad idea. I want to create a map that actually tells which direction the grass should be pointing. So if you drive over it, all of the grass will bend over underneath your wheels. And so you can walk on it and deform it. And we can actually also implement that with all of our wind. And that way we can actually bend that map instead. I'm thinking with a compute shader. And then we can actually have it have springiness, so it can actually spring back up and actually simulate some kind of physics. I don't really know how that's all going to come together. We're just going to get the map working in this video, and then we'll build on it until it doesn't work or it turns out awesome. So no idea how this is going to go, but it's either that or lighting. And this seemed more interesting, though lighting's pretty cool too. So we're going to get started with that. Before we do though, I have been refactoring things a bit. So somebody pointed out in the chat or in the comments, I don't remember who, I don't have their name unfortunately. But if you call restart strip when you're running to this try stream, it commits whatever you've written and then starts a new one. So in this case, we have this triangle stream and I am now building quads. So I give it the 4 points that will be in the quad. And then this just automatically pushes each of those onto the stream. And then we get our point. So this makes it way easier. We cut down, we had 100 lines to draw all of this because every single vertex had all of this. Now we just have that once and it's way easier. So now our drawing code actually just looks like this, and then we just call it build quad, which for the most part has worked out a lot better. And we didn't have to worry about the duplication anymore because we have that restart stream. So what we're going to be doing mostly is taking out, there is a V1. So we currently increase by the normal. We're taking that out and actually going to be looking up a map. So we've got our texture coordinates that's actually already being passed in. So we just need to actually grab that somehow. And then we just need to do a texture lookup there. And that should be everything we need. So from here, grab our texture, throw it into everything, and then use that instead of the normal angle as our thing. And that way we can just plug textures in to kind of alter the direction of the grass. And we'll probably be pulling the wind out too, just temporarily, while we work on this solution. So that's what we're going to be doing today. That's weird. Why is that overlaying? Okay. Resharper, sometimes you're weird. All right. So we need, I forget what I need, this. So we need to set up our UVs. So we aren't actually doing that right now. We have these vertices, indices, colors, and normals. So let's do our mesh and set the UVs. And so I'm not going to set this traditionally. The UV is actually, since it's just a point, the UV is actually going to be based off of the position. So how this is going to work is it's going to be the points position minus the origin divided by some value. So that way we get a scaling. We can make it really dense if we want it to repeat a bunch, or not dense if we want it to be really big and spread out over an entire field. So set UVs. We are going to, oh, one sec. We want our UV equal to, I can't actually just do that here. We're going to need to build another list. Even if it's just going to be another vector3 UVs. So this isn't great, but we can do this. We could theoretically do this in the shader too. There's no reason we couldn't do that. Doing the calculation in the shader would work, but this is a one-time calculation. We only need to do this once. If we do it in the shader, we're doing it 60,000 times or however many graphs we have every single frame, which seems like a waste. So we're not going to. It would be it'd be significantly faster. All of this code would be way faster in a shader, but it just doesn't make sense to put it there. So we're not. So let's see, we have our grass. I'm gonna make a public float UV scalar, and we're gonna call this like 1,000. And so the idea here is if you give this a number, how do I want this? UV size 1,000. Yeah, we'll see how that works. I have my doubts, but we'll see. So if our physics hits, we need to do UVs add. We're going to add a not a new vector, so we could just do origin minus this dot transform dot position. Remember, we only need, UVs are just x and z. They're just, well, they're two-dimensional. We have a three-dimensional vector here. So we're actually going to need to trim this a bit. So I'm going to store this at a temporary variable just to do these calculations, and then we're going to pull out the two we want, and then we can set it. So position, this is just getting the difference. The order in which you do this is going to depend if you flip one way or the other. So it's going to kind of depend which is up and which is down. But we can kind of work with that later. And then we need to multiply this by our UV scalar. Do I want to multiply it? Sure. I think I want to multiply it. I'm like 95%, I'm 90% sure. So the reason we want to divide this is, say we get something that has 5 pixels between it. If our UV scalar is 5, that means we want that point to be at 1. We want it to have a point at 1. And if it's 10 away, we want it to be at 2, obviously, because you'd repeat twice to get to 10 from 5. So division is what we want. Multiplication would make things go the opposite direction. So we just need to start working with really tiny fractions, and I don't want to do that. So let's use our UVs here. Or not. It's expecting a list of vector 2s. Actually, it's expecting a submesh. We can do that. Okay, so we give it the UVs. That's still the wrong point, though. I don't want to do this, but I'm going to. UVX and UVZ. Because we're working in 3-dimension, Y is going to be up and down. We don't really care about that because this is all going to be layered across a terrain. So that Y coordinate just is the height, and for UVs that doesn't really matter. So we're going to ignore that. And so we're just going to grab X and Z and then pass that in as our UV value. And then I'm going to want a new texture here. So we're going to call this our deformation map. So this is just a normal map. I said that weird. It's just a normal map. There's no anything here. I'll show you what one of them looks like actually before I do this. That's gonna not compile. But this is, there we go. This is what they look like. So this is going to be blue is sort of the Y vector. It's RGB, so blue is the Z vector, but it's Z relative to the point. So this is all in point space, I guess is the object space, not object space. Anyway, so effectively what this is doing is blue will be out, and then in the middle there, you'll notice these normal maps are a little bit weird because they encode a unit vector into a image. and then that's used as a map. And so neutral colors, so 75, 75, or 78, 78, 78 is going to be 0, 0, 0 in your vector, which is the middle of your color. And then if you do like black, that would actually be -1, -1, -1. I don't know what that is normalized. It's going to be like 0.6, 0.6, 0.6 or something. But anyway, that's sort of how this is working. So red is going to be on the X, Y is going to be green, and then blue is going to be Z. So Z would be facing directly outwards, and then everything else is going to be in a different direction. It occurs to me that by my definition, green is going to be up, because that Y is going to be up. This is going to be world space orientation, which wasn't what I was originally thinking, but that's fine. That's how we're going to be using these. So each of these should be a unit vector, assuming I made this correctly, because I just threw this together quick. So this should be straight up. These ones are going to be off to into the Z direction in world space, and then these ones over on the side are get red, and that'll be on into the X. So theoretically it should do like a weird wobbly thing. Anyway, I have vertical and horizontal, and I can grab some other normal maps or just throw random textures at this thing. It'll figure it out. So what we want is a deformation map. Sure, color. And we'll default this to 0, 1, 0, 1. So that'll be directly up in the Y direction. And I'm wondering, I don't think we need to worry about negative values at all. Because normally in a normal map, you can have things like way off to the side or something. I don't think we need to worry about that. And the reason for that is it'll just be flat against the ground, won't it? Like if this is 1x, that'll just be flat against the ground. So I think we're going to try this with just normal stuff. My calculations may not work anymore, but that's fine. Just kind of thinking of this on the fly. I have never done this before, so I have no idea how well this is going to turn out or what to expect. It's just sort of on a whim. So we need a new sampler, which is going to let us actually pull the data out of this. And then since we were going to just do that, I think I'm going to need a lotted version of this, but that's going to work out. So where is it? Perpendicular angle. We have our normal here. So I'm going to need to calculate that. And that's where this texture is going to come from. This value is going to replace this normal. So float 3 of our normal is going to be equal to the texture from the input UV. And this should be coming from our V2G, which is going to contain our vertex information, which is going to include a UV, which we passed in from that script we were working on. So now we have a normal. If I swap that in like this, so we get a normal and multiply that by the grass height. Yeah, I think that's it. I don't know if there's anything else, but we're gonna see. Well, that didn't work. Unexpected token instruct at line 44. Oh, semicolon. Ha. Ooh, it really didn't like that. So again, it can't find that text2d command, so you need to do the lod text2d, which I don't really know the reason for that, but that's that. Oh, right, because this input is actually an array. So we actually have to index into there, even though we're only saying there's going to be 1 point coming in. It's still an array of points, so we have to actually index into that. And then this one. Now I have to figure out how to actually do this. We've done this before, and I always forget. Oh, it's right up here. Ha! There we go. So we're reading out the color from our main texture. That's kind of weird. Don't know why we're doing that. I may not just remember what was going on there. But anyway, we're reading it out here and passing in our texture coordinates, which we can then duplicate here. And so theoretically that all works. So, nope, still doesn't like it. Okay, fine. What did we say our UVs were? Float 2. Does it not like float 2s? It's expecting a float 4, it looks like. Oh, this is totally gonna screw up all of my layouts. I hate that like all of this is connected. So when I resize this, it pulls this window over. Really don't like that at all. That's the wrong project. Let's see here. So we need a way to make this a 4-dimensional vector, and well, this will probably work. Sure. Float 4. Done. Okay. So we have winds still, so this is going to be a difficult example, but it is up, I guess. That's the best way I can describe it. It's up. So, whoa. Well, that doesn't like whatever I'm doing. Alright, so we need to modify this a bit. Did I edit the wrong thing? Why don't I have... Oh, I just gave it a color. Derp. That's not gonna work, is it? How didn't that... Okay. Weird. Everything's fine. We can fix this. This needs to be 2D. There we go. I don't think this works, but I'm gonna try it anyway. I think you only get white and black. No? Okay, cool. So I gave it green. So the default texture should theoretically be green. I don't actually know if that works. We can find out real quick, because I can do something like red. I feel like that's not actually doing anything. I'm going to leave it though, and I'll look into that and see what's going on. I won't have an answer in this video, but that'll be there. Let's see here. Let's grab our orientation map and drag this over here. Okay, this is great. Wonderful. I'm actually going to try to get this to regenerate. There we go. And I'm going to shrink it down and make it 2,000 grass instead of 60,000. And that's just for my own sanity. I feel like I don't know what's going on. It doesn't look like it's grabbing the normal anymore. But it all kind of looks like it's going the same direction. This is going to be impossible to tell. One sec. Let me... Wind speed strength. Done. So, the wind no longer has any effect. And let's do one more thing. Is this a good idea? No, not really, but we're gonna do it anyway. I'm gonna grab our normal and use it as the color. And this way we should be able to actually debug this, I think. Let's see, return normal. That's not gonna work. We set it as the color. So in.color. And I'm just gonna quickly comment all of that out for now. Might have commented too much out. There we go. All right. Invalid color G2F. Where are you? Diffuse color. There we go. I had the wrong name. This is going smoothly. From float 3 to half 4. Wrong project. All right. So we need a half 4 with these. We're going to take the RGB values there. We just need a alpha. So I can just plug that in, and this will be magic and make me a 4-dimensional thing. And this shows that my normal is definitely not ending up where I thought it was. Or I'm just reading the wrong thing. Diffuse color. Let's see, we're building our quad. Color is there. And we pass in the color as our normal. Input.uv. So this input is coming from our vertex to geometry input, which will come out here. And so that UV should be coming directly from our texture coordinates. This is weird. So we get our texture coordinates, we do our lookup, we get a normal, we write it into the color, and then we draw everything with that color, which we're passing in here. And then that diffuse color should get printed back out and used. Because we don't do any transformation here, we just take the color and set it. So I don't know what's going on. Unless there's something weird going on that I'm missing. Yeah, I should definitely be able to change these and see difference. Why is it just green? That doesn't make any sense to me. Huh. Yeah, okay. This is unexpected. I don't know what's going on here. That diffuse color should be printing the result from this normal. Oh. I see the issue now. We're still using that stupid main texture. Got it. Okay, good, good. I know the issue now. Now we need to figure out why they're all the same. Because even though we were using that, we should have been able to look from the top and sort of see our material. Like, I should be able to look now from the top of this and be able to see this deformation map reflected here. And I don't. Which makes me think something's broke. I see it now. And I punched my microphone. Nice. Our scale was huge. It doesn't explain why it's grayscale at all. Okay, thank you for that. That's not what I wanted at all. Since we're not using these as normal maps, I'm going to switch them back to default. There we go. Got it. All right. So this is what I was talking about being able to see our material or our deformation material. We can actually tell, like, this is the orientation or this is the orientation, one of the two, of what we're seeing. And it has like a weird, like, art style, I guess. I don't know. Definitely not efficient in any way. But we can use this now because it actually works. So I'm going to take out this normal nonsense. We don't need to do that anymore. Draw the normal. And then I'm just going to... that won't get me that back. Either will. Okay. There we go. Cool. So now we're back to what we had, and things should now bend differently. Probably would have been easier to see if I hadn't just removed that. Actually, it'll be even easier if I move this. Ooh, that is the wrong thing. I move this over here. Yeah. So I don't know how well you can see that. You might need a pretty high resolution for this. But the grass actually gets taller here. And then it kind of shrinks off to the side. You can see it kind of sweeps out. And then goes this way. And so with this, we're actually able to sort of deform our grass based off of this texture. And I can change it just by dropping something out. Well, that's the same one, so that's not going to do anything. But if I drop something else in, it changes. Which, this one you can actually kind of see, because the sides both have they're both higher. But anyway, this is cool, not because we're just able to like statically define how this looks. It's cool that in that sense, but not super cool. What I'm looking for is, I want to be able to like write to this texture file in real time and actually modify this. So if you have a vehicle draw across there, we can write to this texture with the vehicle tracks, maybe even writing the vehicle's velocity for those tracks. And that will actually move the grass in that direction. We can even like use velocities and things, and we could theoretically throw an entire physics simulation into this if we felt like it. And obviously there'd be it wouldn't be perfect because we're not actually simulating all the points anymore. We're simulating this entire map, which is probably going to be slower. But that's fine. Well, will it be slower? We'll find out. Either way, that's what I wanted to get through with this video. It took a bit to get here. Next step, I want to actually be able to update this. So I'm thinking by default, all of the grass will try to move up. So we'll give it some sort of springiness factor that will define how far up it can kind of move itself, like per second or something. And then we'll just sort of like lerp every value in this texture towards that value every frame. And then we'll see what happens. So the grass should all stand up, and then we should be able to like knock it down again, and then it should slowly stand up again. And we could even theoretically have like a springiness map. So if you drive over it, it doesn't come up as fast as if you just like walked across it softly. Or if you're like running, it leaves a trail for longer than if you were just like, I don't know, sneaking along, which could be cool for like a stealth game or something. I don't know. I think there's a lot of interesting things we could do with this. I don't know how efficient this is. We'll probably get into that later. I just kind of wanted to see what would happen. So we'll see where this goes. But that's it for now. So if there's anything else you guys want to see, any ideas you have, any suggestions you have for me, I'd love to hear them. That's where I get all my ideas. So yeah, that's it. So until next time, see you, Internet.